everyone, my name is Ananya and I'm back with Milestone 4 for advanced data management. So, in this milestone, I will discuss cluster troubleshooting and performance analysis, then ETL or data pipeline design and implementation. I will generate some vector embeddings and then I will do some similarity search on those vector embeddings. And towards the end, I'll discuss how we can refine the data for AI and followed by some normalization techniques and then AI disclosure. So the first part is MariaDB cluster troubleshooting and performance analysis. So in this, I will discuss Kalera's cluster recovery, cluster health, basically its state and membership status, then query and system performance. So I'll first discuss the Galera cluster recovery. So you guys must have experienced this, that when you close all your Galera servers and then when you come back and reopen, restart them, you cannot bootstrap just any server, right? So here also, as you can see, I was trying to bootstrap my Galera servers and I was getting the same error in all the servers. This is because I can only bootstrap one server and I can then restart MariaDB on all the other servers using the standard restart command. So, but how do we know that which server we need to bootstrap? So here there is this file, um, this file you can see, right? So here you see a variable called save to bootstrap. So here the value is 0. That means we cannot bootstrap this server, that is server 2. It is not safe to bootstrap. So I just ran this query in all the servers and I saw that the value is 0 for every server. So what I did was I manually edited the file on one of the servers. Here it is server 1. So I manually edited the file and changed the value of the variable from 0 to 1. So now this particular server is safe to bootstrap. And now when I bootstrap this using Galera new cluster command, I see that my MariaDB is up and the server is in a Galera cluster. Now for the other servers, I just simply restart MariaDB using the standard restart command. And once I've done with all the servers, I'll see that MariaDB is up and running and the size of my cluster changes to 4 because now 4 servers are there in cluster instead of 1. So I restarted MariaDB on all the servers and I'll check the size. You see that the size is 4. That means that our server is healthy and the cluster is healthy basically. Okay. So moving ahead, I ran some of these, like all of these queries on all of my servers. So basically, these are some queries that will tell me what is the status of my cluster and what is the health of my cluster. So these are some queries that tells us the status, if it is connected or not, if it is ready for exchanging log files, if what's the cluster size, what are the servers which are a part of the cluster, so all of that. So if any node is not in the primary state, so if this state is not primary, then that indicates that the cluster is in split brain. So I ran all these commands on all my 4 servers and I saw that the cluster was healthy. And the status was primary for all the 4 servers. They were all connected with each other because this value is on. Then the servers were ready to exchange data. The servers are in sync. The size is 4. And then these addresses set to auto in all 4 of them. So all these screenshots tell me that my cluster is healthy and good to go. Now, second part is the query performance analysis. So in this, I just try to implement how we can analyze the performance of some queries, like how we can check if the queries are slow, if the queries are fast, and what can we do to enhance the performance. So for this, I will use this command to see the logs, and I enable these logs using this slow query log variable. So I set the variable as on, as you must have seen, and then I set the global long query time variable as 0.1. So this means that any query that takes more time than 0.1 seconds, it is considered as a slow query according to us. So this is the basically the logging command, and here you can see all the logs, but I do not see any log related to an SQL query that I ran, right? So what I will do is I will run some more queries. For example, I'll run some all like select star queries. So here it fetched 800 rows, and still the time is 0.001 seconds. That is much lesser than the threshold that we have set for this server, right? Still, I'll just see if I can see this query in the logs. And I didn't see, right? That is expected because the query didn't take much time. Now, what I did was I changed time from 0.00 from 0.1 to 0.001. Like you can, so sorry. Yeah, we were here. So the video was blur for some reason. So um yeah. So what I was discussing that I will just change the query time from 0.1 to 0.001. I will set the variable like that. As you can see here, I've set the long query time variable as 0.001. Now, we have decreased the threshold a lot. So earlier this was 0.1, now it is 0.001. That means any query that takes more than this time is considered as slow. So now I will run some complex queries, and I will, like this is a complex join query that I generated from ChatGPT. Now I'll run these queries again and again, and I'll see the logs that if I'm able to see that. So again, I was not able to see. Now I will again run some more complex queries. As you can see that I ran some more complex queries again and again, and I did some select star on my customer table so that it takes some time. And now when I see the logs, you can see that I'm able to see some queries which are slow according to our set threshold time, right? So here you see the query time, log time, rows sent, examined, etc. So this was my way of seeing which query was slow. Now coming back to the slides, so here I've pasted a small snippet of what I just showed you. Um, to break these logs, these are the values that we should see. So basically, this is the query time. Query time was 0.002778 for this particular query, which is the total execution time. This is fast because the dataset was small. Then we have log time, which is also low. That means that there is no major issue. This is basically time spent waiting for row or table logs. Then these are the number of rows that was actually that were actually fetched using that query. But just to fetch 10 rows, 2230 rows were examined. Then, even though only 10 rows were needed, MariaDB had to scan these many rows, right, across join tables. So that's about 223 times more rows read than returned. This suggests that the query is not using indexes. So what one way to optimize this query is to add indexes in these three tables so that we can like so that we do not need to scan all the rows, but we can just scan a few of the rows. So these are few ways and few commands which you can use to analyze the performance of your query and your cluster. Now, okay, so these are few more commands which I've pasted here for query again. So these are buffer pool reads, pool read requests, threads connected, threads running, slow queries. So just to again tell you a summary about these. So basically, buffer pool reads indicates the number of times data pages had to be read from disk because they were not found in InnoDB buffer pool. A low value means most data is already cached in memory. So this is excellent. Disk reads are minimal. Then buffer pool read requests. So since the server handles most data from memory, this value is high and that is totally fine. Then we have some other values like threads connected, threads running, pool hit ratio, um, then queries, slow queries. So queries are total number of queries executed since our last server start. 272 is basically a low count for a database. Sorry, but it's fine. Then slow queries are the number of queries which exceeded our threshold time, which we set as 0.001 seconds, right? So that means that in total 19 queries were there which were slow, which we can optimize. So these are some ways you can analyze the performance of your queries. And now coming to analyzing the performance of the system. So I ran some more queries and I got this response. And to break it down, I can see here what's the CPU load, the memory usage, the disk and input output weight, the process load, and cluster readiness. So all these metrics tell me that the system performance is good. Um, like most of the time the server is ideal. Definitely yes, because the load is not much on the server, right? This is just small database. Then there are some interpretation and recommendation for the system. So moving ahead to advanced ETL. So here I designed a data pipeline and implemented it. The steps I followed were these. So I created some staging tables, which are some temporary tables. So I didn't load the data directly to main tables, but I loaded the data to staging tables first. I did all the cleaning and transformation stuff in staging tables, the deduplication and normalization too, and then I absorted all the data into production tables. Now, I also showed how we can automate this ETL process using scripts and stored procedures. So basically, in my case, I've used stored procedure, 10 error handling, and AI vector embedding that we will do at the end. So this is creating staging tables and loading data. So here you can see a script of creating staging tables. So I've created a staging table against all the main tables. So staging customers, staging supplies, categories, etc. And this was the script used to load data into staging. So here I'm showing you that we only have main tables as of now in our database. And there is no data in the main tables because I deleted the data. Now I will run the SQL file which I created to create staging tables, right? So after I ran this file, I'll go to MariaDB and I'll see that the staging tables are created. The data is still zero because I didn't load yet. Now I will load the data. then I see that the data is there. There was some issue with order items, so I loaded again. So I got these much data in my staging tables, on which I will do some transformation and cleaning. Now, cleaning and normalizing data. So basically, this is a script that I used to just clean the data that is there in staging tables. Here, basically, I have also created main tables, and I will be inserting data into those main tables after cleaning all in this one script, right? So here, as you see that in the categories, I'm loading clean categories like duplicates are not accepted. Then in suppliers, I'm handling the duplication. So I'm keeping only the minimum ID row for duplicated emails. Normalizing email case. So if the email ID is in uppercase, it will normalize it to lowercase like that. And then some cleaning on customers table. So basically handling duplicates here, keeping only the lowest ID. Then oh, okay. So basically here I'm replacing the dates in my, like, normalizing the dates basically in my reviews orders table. So we discussed about customers. Oh, this is frustrating. Okay, so reviews. Now, what the imputation I have done on reviews is that if the review rating is invalid, for example, if it's out of bounds, or if it is not a numerical value, and if it is not within 1 to 5, then I'll just replace it with null, and then I will replace it with an average value that is 3. So here I've replaced it to with 3. Then we are also normalizing the dates in the review table, and that's it. So this is the clean normalized load SQL script that I just showed you. I will run this script. I ran the script here. So I ran the script here, and then I saw that the data was loaded into the main tables also. And if you see, there is some difference in the data, right? For example, in the staging customers, I have 1,000 number of rows. In the main table of customers, I have just 902 rows. That means that some data is less in the main tables. That is because there might have been some duplicates, right, which got filtered out in the data cleaning process. So we were able to load clean data from staging to main tables, and now I will show you how we can automate this process. So we can automate ETL using stored procedures because of encapsulation and because of reusability. So instead of executing long ETL scripts, we can simply call the procedure and let it do the work. Performance, so procedures are compiled and stored on the database server itself. So when they run directly, they lead to better performance than sending raw SQL commands from an external application. Now, the stored procedure that I created is to automate the engine for the reviews ETL process. So this procedure ensures that data moving from temporary staging reviews table into final reviews table is cleaned and correctly merged every time it runs. So what this procedure does is it actually automates insert. That is, if it will insert the review if it does not exist in the final main reviews table, and if it already exists in the table, it will update it. Then it also does the data cleaning transformations. For example, uh, if the review rating is invalid, for example, you see here, right? So if the rating is out of bounds, for example, if it is 6 or 10, then it is averaged to 3. And if it is invalid, then also we are uh, like normalizing it. So this is the procedure code. So to perform an upsert, um, and then to change the transform the data basically. Now, once I created this procedure, I will show you how it worked. So I created this procedure, right? Now I just called this procedure, that is batch review ETL. Now, I okay. So here you see that I am inserting some data in my staging reviews table. So not in the main table, but in the staging table for now. So I'm inserting some like dirty data, right? And then I will um, call the procedure, and I'll see that the data is inserted in my main tables, that is reviews, right? Then I'm updating some data in staging table, and I'll again call the procedure, and I see that the data was changed, right? So I changed the review rating from 5 to 2. So here it was earlier 5 in my main table, and I changed the data in the staging table. Now when I'll call the procedure, I see that the rating is changed from 5 to 2. You see, I didn't directly made any change in reviews, but the procedure made these changes, right? Now I will be testing cleaning. So I tested insert, I tested updates. Now I'll test cleaning. So I will insert some bad data in my staging table. So so this is a clean insert. This is fine. This is a wrong insert. So I see the rating is non-numeric, right? Then this rating is out of bounds. 9 is out of bounds. So I'll just copy and insert these in staging table, and then I will call the procedure again. Now I'll see the same data in the main table. So you see, right, that the first row was clean, so it is inserted as is. The second row, the rating was non-numeric, so uh, we replaced it with the average rating, so we imputed it. Then the third row was also like the rating was out of bounds, so we averaged it out. And replaced it with 3. So this is how we can automate the ETL process and make our ETL more robust. And these are some screenshots again showing the count of the main tables and staging tables in the other servers. So server 1, server 2, 3, 4. So the data is in sync in the cluster. Now we move to the last part, the second last part, MariaDB vector embedding generation and similarity search. So basically in this I will generate some vector embeddings and then I will do some similarity search. Now for this I first created a Gemini API key using Google AI Studio. So here you can see the key, you can just copy it from here. Then I created a .env file in which I pasted my Google API key. I pasted my user password, the host, and the database name um, for MariaDB, as you can see here. Then I added 2 columns to my products table. So I didn't create a new products table because I already had it in my database. I just added 2 columns called description and embedding. So the embedding that we have opted here for is for the like the dimension of the embeddings will be 768, right? As this is a type vector 768. Now, this is the command that we we got from Dr. G to install some dependencies before we run our Python script. This is the Python script that we got in class. So it will create vector embeddings and descriptions, and it will store uh, these data into the products table. So I just ran that uh, file that I just showed you, right? The code that we got in class. This is the generate description and embeddings file. So as you must have seen that the limit was 5. The batch size was set as 5. So my embeddings were generated in batches of 5. So I had to rerun the file after 5 uh, iterations were done. So as you can see here that embeddings are being generated and successfully stored into the products table, right? So I reran the files until all my embeddings are done. Then once the embeddings are done, I will I'm here searching for similar products. So basically the semantic search I'll be doing. So for that, I altered my products table. I modified the uh, embedding column to not null. Then again, I added a vector index to ease out the searching. This is the code for this is the Python script for the semantic search. So here, this is my query, like a gadget for my kitchen. So all the descriptions which are related to this particular phrase will be seen in my response. So this code was also given to us in class. So once I ran that Python code semantic query.py, I saw these 5 responses uh, for my query. So this was the vector embedding and similar semantic search. Now, coming to the last part, AI data preparation. So, our goal is to improve embedding quality and AI-driven semantic accuracy. And for these things, we can enhance, we can like use any of these methods, right? We can do some feature engineering, text normalization, embedding regeneration, numerical normalization, etc. So a little like to touch upon them a little bit. So in feature engineering, we can combine columns like product name, category price, and supplier into like a single text. Then we can add some contextual metadata for richer embeddings. This will result in improved semantic clustering and search relevance. So basically, we are making our like prompt, you can say, much more detailed for better results. Then we can text, like normalize our text, like we can convert all the text to lowercase for consistency, remove punctuation, extra spaces, and make our text you know good and clean and readable and uniform, so that it is easy for our embedding to search phrases. Then regeneration. So the model that I used in this embedding creation that we discussed just now was 004. It is simple, it is cheap, and like we can also replace older embeddings with normalized and context-rich ones. This will enhance similarity accuracy. Now, numerical normalization. So this makes our system future-proof. So we can normalize numeric fields like price. We can enable combining semantic similarity with numerical proximity, which will support future advanced recommendation systems. Um, so the result of all of these will be that our semantic accuracy will be improved, and so will be the retrieval precision. The AI explainability and data consistency will be better, and our foundation will be ready for more scalable and hybrid AI models. Now, the AI disclosure. So, the tools that I used were ChatGPT and Gemini. I have used Gen AI to help me generate some code like complex testing queries to test the query performance. Like I generated some complex queries with joins and nested queries to test the performance. The benefits of AI was that I was able to understand the vectors concepts faster. AI was the real-time debugging assistance for all the issues I faced. Many times I was facing errors implementing all of the stuff that I discussed. So I went to AI to debug. Then the writings or the content that I got from AI was also professional. So, for example, for generating this PPT, I used AI to generate some content that I can paste. Limitations is that it definitely requires human validation. I cannot just blindly trust what it gives me. I had to like put in my efforts also. Then the impact is AI acted as a learning, debugging, and reasoning partner for me throughout the milestone. So that's what and that's it is. Thank you so much for listening up till here. I know it was a long video. So if you have any queries, suggestions, you can reach out to me. So thank you so much. Have a good rest of your day ahead.